Hello and good morning, dear students, and welcome to Vista's Learning, an online educational platform. My name is Denzil, your science tutor for class 11. So let's get started with today's session. Today's session is based on a bridge course, which would be an introduction to calculus. So let's get started with the session. This is a session 3 of this bridge course. All right. Now, when it comes to talking about the fastest land animal, which do you think is the fastest land animal? That's right, you guessed it right, cheetah. But let's take the case of a human. Humans are fast as well. But when compared to cheetah, it is not that fast. Let's take a look at another clip. So you see a cheetah that's chasing a gazelle and this human. So now who do you think is the fastest land animal? It's still a cheetah. This is just an animation, but not just a realistic, all right? So what I wanted you to know here, what I wanted to observe is how do we approximate the speed of a given object at that given instant? Let's take an example of your scooter. When you go in a scooter, what you identify is that the speedometer increases as you accelerate. That speedometer, the needle which increases, tells you the speed exactly at that moment of time. So how do we define it? Do we have any mathematical equation or proof where we can find the speed of a given object at that time? What we have, the definition of speed, where speed is equals to distance by time, is not the speed at that moment, it is the speed for a whole journey. When you say the distance between one place to other is 40 kilometers and it takes about half an hour to reach, so what would be the speed? 20 kilometers per hour. So which means you have calculated the speed over an entire journey. So to identify the speed exactly at that moment of time, we use a tool in mathematics that's called calculus. So what is a calculus? Calculus is a broad area of mathematics dealing with topics such as instantaneous rate of change, area under the curve, sequences, and series. Instantaneous rate of change is exactly what we need. Rate at which the speed changes, rate at which the distance changes over a given period of time. Let's take a look at this by an example. In mathematics, you might have learned in lower sections as to how to find the slope for a given curve which can be plotted on a graph. So those of you who are finding it difficult to understand this mathematical concept, I shall make it easy to you in this session. So observe, take your notebooks out and make note of them as I proceed. So let's get started. First of all, for a given graph sheet, you draw two reference axes which are mutually perpendicular to each other. One axis is a vertical line. This axis is called the ordinate or the y-axis. Another axis is a horizontal line which is called the abscissa or the x-axis. By plotting the points on the graph, you can construct a straight line such as so. So by plotting the points on the graph, you construct a straight line or a curved path, but we consider here as an example, let's say a straight line. Now to this straight line, I need to identify what is the slope. So how to identify the slope? Now here's what you do. Pick any two random points on this straight line. So I'm going to pick any two random points, one point located here. Let me use a different color for that. I'll use the color blue. One point that is located here, the other point which is located here. Now, how do we define this point? The point is defined by a Cartesian coordinate system, which is normally represented by x comma y axis, right? So I hope you all remember that from your lower classes. The Cartesian coordinate system, for a given plane, you have x comma y. Now, to find slope once again, I will project a line downward as well as horizontal from this given set of points. Project a line down, project a line down, project it along the y-axis as well. And now you have these lines that are projected on the x-axis and the y-axis. The point where they interfere on the x-axis and y-axis, I will name them x2, x1 and y2, y1 respectively. So now that we have identified the points x, this is x1, x2, all right. Now that we have identified the points x2 and x1, y2 and y1, we can also mention what the coordinates are. In this case, the coordinate is x1. This x is too small, right? All right, x1, comma, y1, and this point will be x2, comma, y2. Why should it be x1, comma, y1? Notice x1 is projected along the x-axis, y1 is projected along the y-axis for this given point. Now, for this given point, you have x2 and y2. Now, back to slope. How do we calculate slope? Slope, I hope that's visible, where slope is equals to y2 minus y1 by x2 minus x1. So make a note of this. This is how you calculate slope, where it is equals to y2 minus y1 divided by x2 minus y1, x2 minus x1. So you see this y2 minus y1 is a difference in the y-axis. x2 minus x1 is the difference in the x-axis. Since we're dealing with difference in the y-axis and difference in the x-axis, slope can be easily written by a letter delta y by delta x. This is a symbol that's called delta. It's a Greek letter. Especially in mathematics and physics, we commonly use Greek letters, as because most of mathematics and physics contribution, understanding the whole nature itself, the reality, was provided to us by the Greek. Philosophy, mathematics, physics, and lot many others. So that is why we use Greek letters. So delta is one of the symbols that we use to show the difference between the two physical quantity. But here, difference between the two quantities such as y and x. So now that we have learned how to identify the slope, let us try to form an equation for this straight line. You might have learned this in your lower class as well. Equations of a straight line. It's not just that, you would have also discussed equation for a pair of straight lines, or the chapter, to be more specific, is a pair of linear equation. When I use the word linear, it just means a straight line. So pair of linear equation, you just didn't learn one straight line, you had learned a pair of straight line, meaning two straight lines. What happens when they cross over each other, what happens when they're parallel to each other, and what happens when they are when they're coincident, when one line is overlapping another line. So now let us just try to recap what is the equation of a straight line. Now to determine the equation of straight line, first thing we need to identify the function here. Function meaning the relation between y and x. The same relation that you carry with your friends and family members, the same relation we're going to set here with y and x. So for a given function, let us say f, a function defined by f of x. So this is to show you that the given function is of a variable x, which is equals to y. So y is a function of x. For a given linear equation, meaning for a straight line, y equals to mx plus c. This is the equation of a straight line. So go ahead, make a note of this equation of a straight line. Maybe in your textbooks you would have studied as ax plus by plus c equals to 0. This is also the equation of a straight line. But here I've written as y equals to mx plus c to show you that y is a function of x. So if it is a function of x, it means y is a dependent on x. But x, as so we know, is not dependent on y. So this becomes an independent variable, and this becomes a dependent variable. So why are we learning to find a slope? Now our objective once again is to learn about calculus, but calculus starts from this basic model of understanding a slope, and like we move on to understanding the limits. So this combination of slope limits is how I can proceed in help you understanding calculus. So finding limits. Now what is a limit? You must have seen the signboards, the street signboards where they mention speed limit equals to 3. So what happens if you go beyond the speed limit 3? But here it's not been specified as to the unit as meter per second or kilometer per hour or miles per hour. So we do not know what the speed limit exactly, the SI unit is, but let's say 3 units. Okay, speed limit is 3 units. So what happens if you go beyond the speed limit 3 units? Well, bad luck. If a police catches you, then you'll be in trouble. You'll be put in jail if you go beyond the speed limit. So which means you have to stay under the speed limit. So is a limit applied to a function. Now one such function we noticed in the previous case was this: f of x equals to y equals to mx plus c. To this function you will apply a limit. Just like a speed limit, you will also apply a limit on this function where it cannot go beyond the limit. So let's have a look at it by an example. So here I have again a graph sheet. All right. So once again we draw a reference axis, which is the ordinate or the y-axis, abscissa or the x-axis. Now for this we will draw a straight line by plotting a bunch of points, and then we construct a straight line. Now that we have a straight line, we need to identify the slope. Go ahead, try to identify what is the slope. And how do you identify the slope? Select any 2 points on this straight line. Step number 1, select any 2 points on this straight line. Step number 2, project lines to the x-axis and the y-axis. Done. Step number 2, complete. Step number 3, identify what are the points on the x-axis and on the y-axis. x2, there's an error there. Let me correct it. All right, so x2, x1, y2, y1, and find the slope, where slope equals to y2 minus y1 by x2 minus x1, which is nothing but delta y by delta x. So let me put that as slope. Now what I'm going to do next is, for this slope, I will apply a limit. Now, how to apply a limit for a given function? Let's say if a function is defined by f of x. In order to apply a limit, first you write LIM to show an abbreviated form of a limit. F of x, so which means the variable that we're dealing here is x. So x tending to a certain number, let's say I, where I can be where I can be an integer. This is how you apply a given limit for a function. Limit where x tends to I, where x is called the variable, I is an integer, f of x. Very simple. So we are going to apply the limit, same case for this one here. So when you apply the limit, you get limit. So taking only the right hand side, you have to also apply to the left hand side, but I will apply to the right hand side first. Delta x tending to 0. You notice what I've written here? Delta x tending to 0, delta y by delta x. So what does this imply? Delta x is tending to 0. The limit what I've applied here means delta x is the difference in the x variable, so which is x2 minus x1, where it is tending to 0, meaning this particular difference is narrowed down to a single point on the single point on the straight line, where it is almost tending to 0. It is not equals to 0. Let's put that clear. It is not equals to 0. It is almost tending to 0 at infinitely small value, not infinitely small, but very, very, very insignificant small value, where you see that the difference between the two almost tends to a single value on the x-axis. So this particular value on the x-axis will give you an exact value on the y-axis. Now, where can you apply this? Is there any application that is based on this? Yes, truly there is. First of all, these type of changes are what are called as instantaneous rate of change. Now, the application that is based on this instantaneous rate of change is instantaneous velocity. Just like the example that I gave you, when you're riding a scooter and when you accelerate, you see the speedometer needle changes. That speedometer needle is showing you the speed at that exact moment of time. If you increase the speed, does the needle turn after 5 or 10 seconds? Yes? No. When you increase the speed of the vehicle, when you accelerate, immediately the needle changes, it rotates to show you a different speed. So let me repeat that question one more time. When you increase the acceleration, does the needle take 5 or 10 seconds to show the speed? No, it shows you instantly. When you accelerate, immediately the speedometer changes its needle, its quantity as different. So this is to show you that in mathematics we call this as an instantaneous velocity. And how do you find an instantaneous velocity? Is by using this tool called the limits, where limit delta x tending to 0, delta y by delta x. But in this case, we have y-axis and x-axis. If I replace the y-axis by difference in the displacement, okay, if this was displacement axis and if the x-axis was a time axis, then the change in the displacement over time, where very small fraction of time is what gives you an instantaneous velocity. A very helpful mathematical tool in order to identify such physical quantity. So this limit as one function delta x tending to 0, delta y by delta t is also written as dy by dx. This dy by dx is what is termed as a differential equation. Differential equation, equation that can be constructed using the difference in the functions or difference in those variables, especially when you're using the limits onto a given different. Oh, this is x. Why did I write t? It's because still I'm in the instantaneous velocity mentality there. So this is delta y by delta x, which is dy by dx. Now, as we know, y can be defined which is equals to f of x. So which means I can rewrite this to d of f of x by dx. So make a note of this and what a differential equation is. So the origin for this differential equation, we start with the basic understanding of what exactly is a derivative. Okay, so once you've made note of this, we start with a derivative. To help you understand the concept of a derivative, here's what I'm going to do is take a graph sheet, and onto this graph sheet I'm going to plot my x and my y axis, which are usually termed as your ordinate and the abscissa. So you have your y and then you have your x-axis. Now onto this, we construct a straight line. And obviously, this straight line is constructed using the set of points. And if the set of points are in linear, you draw a straight line. If the set of points tends to curve, then you draw a curved path. But the equation for a straight line and equation of curved path are different. So we have already observed the equation for a straight line, which is written as y equals to mx plus c. So there's an interesting fact behind that equation y equals to mx plus c. You might be wondering, what are those variables m and c? Because you already know what is x and y, nothing but the coordinates. But what is m and what is c? So when you write the equation, which is y equals to mx plus c, m is what is called the slope and c is what is called a constant. So two different variables, again, these are constants, two different constants. One is called a slope, the other which is called a constant. All right, so, oops. Let's construct it one more time. We have to construct this ordinate and abscissa one more time. Ordinate, very good, abscissa, and a straight line. And then identify 2 points to construct a slope, project it to the x-axis and the y-axis. All right. Now, since we know that y is a function of x, so let's take for x here as a variable which is x and x plus h. Okay. Or you can also write it as a constant a plus h. I'm going to write it as x plus h, meaning you've gone an extra distance of h. Now, we know y is a function of x. So at this particular location, we can write this as y, which is a function of x. And at this position, we can write y, which is a function of x plus h. Since at this point, you have x plus h, y will be a function of f of x plus h. To find the slope will be f of x plus h minus f of x divided by x plus h minus x. Now, what is the purpose of doing this? To show you how a derivative can be formed using limits. So to this, we'll also apply a limit where h is tending to 0. So this is how you find a derivative. This is how you find the derivative, which can be written as f prime of h. F prime is to show you a derivative of a given variable, that is h. Now, x minus x is equals to 0. So the remaining will be limit as h tends to 0, f of x plus h minus f of x divided by h. This is how you find a derivative for a given differential equation. Okay, so let's have a look at this by an example where we try to solve and find the derivative of a given equation. So here's an example where f of x is equals to x squared minus 3x plus 5 at x equals to a. Find the derivative. Now, how do we find the derivative of such function? Well, we know the formula, and what is the formula? Is f of x, which is equals to limit as h tends to 0, f of x plus h minus f of x divided by h. So using this, we will try to identify what is the derivative. So we already have f of x. Now we are finding the derivative, so it will be f prime of x, which is equals to limit as h tends to 0, f of x plus h. So all these variables and constant what you see, in place of x, I will substitute x plus h. Okay. So first step is to write x plus h the whole square minus 3 times x plus h plus 5 minus, why minus is because now I have to write minus f of x. So I put a bracket so that we can conduct a sign operation, which is sign multiplication later stage. And then f of x, I don't have to add any other elements, any other variable. So I write it as it is, which is x squared minus 3x plus 5 whole divided by h. Okay. Now simplify. Big equation, I know. All right. So now we'll simplify this. Limit as h tends to 0. Then use the identity, which is a plus b the whole square. So x squared plus 2xh plus h square minus, use the distributive property to multiply, where you get minus 3x minus 3h plus 5, sign multiplication, minus x square plus 3x plus 5 whole divided by big equation. I know. Now let's simplify. X square minus x square cancels. Minus 3x plus 3x cancels. Oh, I didn't use the sign multiplication on 5. So let's use that sign multiplication on 5. Yeah. Plus 5 minus 5 cancels. So let's write the things that are remaining. I don't have space. So continue that. All right. So the remaining is f prime of x, which is equals to limit as h tends to 0, 2xh, okay, plus h square, okay, minus 3h, okay, whole divided by h. Ta-da! We have simplified it from such a lengthy equation to a smaller equation, which is that. And now LCM for all these three is h, so you can separate them, and then you can write where f of x, which is equals to limit h tends to 0, 2xh by h plus h square by h minus, where is that? Minus 3h. Just give me one moment. Minus 3. All right. Minus 3h by h. Cancel the h, where h here gets cancelled. One of the h here gets cancelled. One of the h here gets cancelled. I'm still running low on space. So make a note of this. I will be erasing this part now. So make a note of this. Okay. All right. So okay, almost done. Right. Well, let's continue. So this is where you've cancelled. Now you write f of x, f prime of x, which is equals to limit as h tends to 0, 2x plus h minus 3. Now that you have this equation, apply the limit where h tends to 0. So you put h value 0, because it is so insignificant that you can almost approximate it to 0. And what you're left with is 2x minus 3, which happens to be your answer, or the derivative for the given equation f of x equals to x squared minus 3x plus 5. But we're not done yet. There's one last step. And what is that step? Is that we have to substitute that x, replace in the place of x as a, because it's written f of x, x squared minus 3x plus 5 at x equals to a. So f prime of a will be equals to 2a minus 3. So this is how you find a derivative of a given equation using a tool in mathematics called the limits. So in the next class, I shall teach you how to find using a different tool, which is by using two basic tools or two basic applications, which is differential calculus and integral calculus. So differential and integral. So we will discuss this in the next class. Thank you for joining me. Do visit us at www.we-learning.in to get more details about the classes. I'll see you on the next session, everyone. Until then, take care and have a nice day. Bye-bye.